Hello everyone and welcome to my YouTube channel. My name is Subhashish Mishra and today's topic of discussion is on multicollinearity. So before we start, if you are new to my channel, please subscribe, like, share and also turn on the notification bell so that you will be notified whenever any new video gets uploaded. Okay, so before we discuss what exactly is a multicollinearity, let's understand what is a regression. In terms of regression, what we usually do in terms of regression, we try to find out the individual independent variables relationship with the dependent or the output variable. So how the individual independent variable is impacting the output of the output variable or the y variable. Now let's understand what exactly is a multicollinearity. So whenever we have two or more independent features available in our data set which are highly correlated with each other, then we face the multicollinearity problem. So what exactly is in the relation to the regression? So as we are already discussing, in regression analysis, we basically try to find out the relationship of individual independent variable with the output variable, keeping all other independent variable constant. So for example, if I have a linear regression equation y equal to m1 x1 plus m2 x2 plus c. So here if I want to I want to find out the m1 or the coefficient of x1. So in that case what I will be doing, I will be taking m2 x2 and c as constant, and based on that I will be trying to find out the relationship between y and x, and based on which I will be finding out the m1 value. Similarly, the same thing goes for the m2 and any other independent variables which are available. But what happens in case of multicollinearity, because we have two or more independent variables which are related to each other or are having influence on each other, because of that, whenever we try to find out the coefficient of one independent variable with respect to the output variable, keeping all other independent variables constant, that scenario is not going to happen. Reason why is like, for example, let's take an example. I have A's and I have A's and number of years of experience and also salary. So we know as the most of the cases, as the age increases, the number of years also increases, based on which definitely the salary increases. So here age and number of years are highly correlated to each other. So whenever the age of a person changes, a unit change in the age also puts an impact on the number of years of experience. So if we try to find out the coefficient of the age variable with respect to the output, that is the salary variable, keeping the number of years of experience as constant, is it going to be a constant variable? No, it will not, because it will also have an impact on that. So in that process, finding out the coefficient of the age variable will be difficult. So this is why multicollinearity is a very big problem in a regression analysis, and we have to tackle that kind of scenario. Now there are different types of multicollinearity. So sometimes what happens is like, while collecting the fresh data, we select few features which are derivatives of each other, say age and experience, which I was explaining earlier, which are highly correlated to each other. This type of correlation is called as data-based multicollinearity. So whatever the data we have collected, based on that we have faced the multicollinearity problem. Sometimes what happens, we create a new feature. So whatever the features we have available, for example, that is not enough for our regression analysis, we try to find out or derive another one feature from the existing feature which is being available. So in that case, from whichever feature we are deriving the new feature, accidentally sometimes what we do is like, we do a multicollinearity problem. So this type of correlation is called as structure based multicollinearity problem. For example, let's say we take an example. Let's say everybody starts their job at the age of 22. So that means, based on that, whatever the age of a person, we try to find out the number of years of experience based on. So let's say somebody's age is of 26 years. So that means that person's number of years of experience is 4 years. So we are deriving this feature from the existing age data set or existing age feature which is available. So this in terms create a multicollinearity between age and number of experience. The number of experience is the derived variable that we have created. Okay. Now, to find out the multicollinearity, we how we can be able to find out a multicollinearity between two or more independent variables. The first thing we can be able to do is like we find out the correlation matrix between the independent variables or independent features. That we have already discussed in a practical aspect in our channel itself. If you haven't seen that video, I'll highly suggest go ahead and watch that one, so that you will be able to relate the thing that we are discussing over here right now. So once the multicollinearity is addressed, we got to know that okay, we have multicollinearity problem. Then how to tackle that multicollinearity problem? Because that is going to anyway impact our analysis, right? So we will not be able to find out the coefficient of individual independent variables properly. So there are three different ways using which we can be able to remove the multicollinearity factor. The first one is obviously we remove one of the independent variables which are highly correlated, okay, or having multicollinearity. For example, x1 and x2 are having high multicollinearity, then we can either remove x1 or x2 and then we can perform our regular regression operation. There is another one way is like, let's say we have only two features available, x1 and x2, and from business we got an idea that we can't be able to remove any of them although we do have a high multicollinearity. So in that case, what we will be doing, we'll be doing a dimensionality reduction technique using which we can be able to capture the data of both the features into a single feature. In that way we will have the analogy of both the features, also we will not be having the multicollinearity problem. So this is one case where we can be able to do that thing. So that is also also one aspect, which is dimensionality reduction technique. We can be able to use principal component analysis. We have discussed about principal component analysis in our channel before. If you haven't watched that, I'll link it in the I button and also in the description below. Please go ahead and watch that so that you can be able to correlate. And the third one is, in all regression techniques we have a regularization technique where we penalize the coefficients or penalize the features which are having highly multi-correlation available within each other. So if two or more features are having multi-collinearity, in that case using regularization will penalize the individual features. And that way we can be able to deal with multicollinearity. Now we will be discussing about the regularization and how to apply those regularization like lasso and ridge regularization and also elastic regularization in our upcoming videos, whenever we will be going in a deeper detail into the linear regression. But this is it for this video. I hope you are being able to understand what exactly is a multicollinearity and what exactly is the problem because of multicollinearity we are facing, and how to tackle multicollinearity. If you have any doubt in multicollinearity, you can always put it in the chat or in the comment section below. I will be very happy to address you guys. Thank you so much. I'll see you in the next video. Until then, stay tuned and enjoy machine learning.